Hello everyone. In this video we're going to learn one way to graph piecewise function. Alright, so what you need to know first. It would be nice if you identify the shape of the function. So for instance here, the first one is going to be x squared minus 3, which is obviously a parabola. So we know the shape of the parabola. And if you are familiar with transformation of function, this means shift downward, right? So your parabola is going to be this way, and 3 is going to be here. All right. On the other hand, we know the minus 1/2 x plus 3 is an equation for line. So since the slope is negative, so this one is going to be a line going downward, and we know as well that you're going to go from 3, which is the y-intercept. All right, so the graph that I'm going to have is going to be from 3 and going somewhere downward, right? So now for the piecewise functions, we're going to use only portions of these functions, and what we need to know is what is the beginning of this function and what is the end of this function. And for this means we're going to use the boundaries over here. So we have the g of x, which is x squared minus 3, going to start from minus 2 and end at 1, and those are the value of the x's, so you are required to find the y's as well. And likewise we have minus 1/2 x plus 3 is a line. You're going to start from x1 and ends at 4. All right, and again you have the x's and your mission is to find the y's. So how can you find the y's? Let's start with g of x, which is equal to x squared minus 3, and this is for x in between minus 2 and 1, right? So it's really simple. You're just gonna plug in g of minus 2, and this is going to give you minus 2 squared minus 3, which is equal to 4 minus 3, and this is 1. So it means that the point you are looking for is x is minus 2 and the y is 1, right? I do the same thing for g of 1, and this is going to be equals to 1 squared minus 3, and this is going to be obviously 1 minus 3, which is minus 2, right? Okay, so what does mean here? That the point you are looking for is 1 for the x and minus 2 for the y. Now I'm going to do exactly the same thing with the other function, which is g of x equals minus 1/2 x plus 3, and that's for the x in between 4 and 1. All right, so let's do this. G of 1 is going to be minus 1/2 times 1 plus 3. So this is minus 1/2 plus 3, which is going to be equals 2.5. all right, and I do same thing with g of 4. This is going to be minus 1/2 times 4 plus 3. Okay, 1/2 and 4 cancels out. You're going to be minus 2 in there, right? So this is going to turn into minus 2 plus 3, and this is going to give you 1. All right, I forget to put the points. So the point for the first one, I'm going to squeeze it here. So x is going to be 1 and 2.5 for the y, and for the other one it's going to be 4 for the x and 1 for the y. All right, so now is the time to graph it, right? Let's keep graphing it in the red. So I'm gonna start with the parabola over here. So I'm gonna start with minus 2 and 1, and that's gonna be this point over here, and the second point is gonna be 1 minus 2, and that's gonna be 1 for the x minus 2 for the y's. So now I know this is a parabola. However, I don't really know how far you're gonna go, right? So if you are familiar with transformational functions, it means the vertex is gonna be at 3 really. So there is an extra point that I can get here, all right? And probably I can use the axis of symmetry as well, so that's another point over here. But anyways, if you don't know, just make a small table and plug in any number between. For example, I can plug in g of 0 here, which is 0 between -2 and 1. That's going to be 0 squared minus 3, which is -3. And this is the point that we were talking about, the vertex, which is 0, -3. All right, so you can find it one way or another, right? So this is 1, 2 point, this is 2 point, and this is the third point. And you can connect them together the best you can. Make sure that this tangent over here, you're gonna go this way, and then you're gonna go this way. All right, my graph is not really precise, so let me do better. All right, I guess that's the best I can do, but we get the portion of that one. Now for the other one, we have 1 and 2.5. So 1 here and 2.5, you're going to be somewhere here at this point. And I have 4 and 1. 4 and 1, this is going to be this point. And I know this is the line, right? So that's the beginning and the end, by the way, right? So just try to trace a line. I don't have a ruler here, so let me do it by hand. So this is going to be the line starting and ending, right? Okay, now we know the whatever happened between the 2 points, all right? However, we are missing one important part in this, and this will be the equal sign. Do you see it here? So whenever you have an equal sign, it means that the point is going to be shaded. Whenever it is strict inequality, it means it's going to be a circle. So having said that the point here for 1, so that's on the g of x equals to x squared minus 3, and that's going to be at 1, all right? So this is the point. So the point has 1 and -2. So 1 minus 2 will be this point here, and that's going to be a shaded point. For the other point, we don't have equal sign, so you're going to be simply a circle, empty circle, right? And then this is the graph. So empty circle, you graph it, and then you make shaded point. And since for the other function, which is the line, both of them are equal, there is no equal sign, so both of them, they're going to be empty circles. So empty circle here and empty circle here, all right? So in the end, if it is equal sign, it's going to be a shaded point. If it is no equal sign in it, it's going to be an empty circle. And I think that's it.